Okay, so today we're going to talk about confidence nope. Today we're going to talk about testing parameters. So we're going to test for mu's and for proportions. What kind of test do you use for proportions? So what do you call it? How do you start? I got it? That is the name of the test. Okay, what do you use for means? One sample. Good. Very important, don't you think? What do you think would happen if you did a problem and you did a Z instead of a T? You might get a 1. Okay? Uh-huh. It's pretty fundamental. No, because you're going to check conditions. Something in there is going to be right. Okay. Now, conditions from memory. Now, this is proportions, okay? Everybody brain switch to proportions? Okay, random. And it has to say it, simple random sample, SRS, or it has to say that it's a random sample, or if it doesn't, you say, I assume these 324 trees were a random sample, okay? No cheating, no looking anywhere on the floor. We're right here. Okay, random. What else? And what do you prove for independent? And you plug numbers in here, and then you write, we assume there are 320 students in Miss Becker's class, or whatever. And then what's the last one? Because these are P's and Q's, right? Okay, and so and who are they?
Those are
from the population. From the population, not from the sample. Now, remember, we use 10. What do some books use? So if you see that multiple choice, just go with it, but for your free response, you're going 10. Yeah?
If you only have a P and a Q from the sample, can you just put hats on?
Yes. Yes, and that's a really good point. So let's say you're doing a problem and you don't have, except you're gonna because you're testing here. If you don't have population data and you're forced to use sample data, you best be putting hats on top of those. So make sure it makes sense, okay? If you're using population, which is what you want, no hats. If you're forced to go sample, then put hats on them. Okay, let's go t-test for means. Now, normal is either and prove. No strong skewness, no outliers, and you do that with a box and whisker. You don't have to use a box and whisker, but that's what you can do. Yeah, you plug your data into your L1, and then you go second y equals, which is your stat plot. You turn it on. You go over to the little picture that shows a box and whisker that has the outlier ... You hit that, and then you go zoom 9, and it just magically pops up. Yes, if it says that it's normal. None of them are going to say that. Okay, do you guys know that this is giving us the green light for being normal? Like, because proportions aren't like a fluid curve. So with the large counts conditions being met, it allows us to approximate it with a normal distribution. So both of these conditions are a normalcy kind of, they allow us to do the inverse norm and the inverse t and all that stuff. Everybody good on their conditions? Okay, awesome. Let's see what's next. Okay, so now grab this guy. And if you want to make any notes on him, feel free. But we're just going to kind of talk through him really quick. So what are my 3 categories? Proportions, means, Do you remember the matched pairs difference? Not differences in I have two completely different samples. This is matched pairs. I test you in statistics before the class, and then I teach you stats, and then I test you after the class. So this is a matched pairs. And if you'll look at the formulas, well, we'll get there in a second. Okay, so are we good here? Are we good here? Are we good here? And here? Don't be lazy, but don't state something that's not true. Cover your butt and then get out. Are we good here? Okay, and I have that right there just to clarify. Okay, set your null and your alternate. These are always based on parameters. This is a fantastic multiple choice question, is to give you 5 options of a null and an alternate. They're going to give you 3 that have parameters and 2 that have statistics. You mark out the 2 that are statistics because that's not an option. You'll never have this with an X bar, and you'll never have these with a P hat. Your null and your alternate are always mothership kind of parameters. Your null is always an equals. Always. No matter what, it is an equals. Your alternate is either not equal to, greater than, or less than. You have to read carefully. Okay, read carefully. Your level of significance, they're either going to tell you or you're just going to set it at 0.5 or 0.05. And remember that we usually write that underneath our null and our alternate. And I think in doing my free response for tonight's homework, I forgot and had to go up there and just write them in. Test statistic. Okay, so after you check your conditions, this is where I panic. Oh, crap, I don't know where to go next. Look at your formula sheet. On the back. Do you see where it says test statistic? Okay, so guys, the concept behind this is you are finding a Z or a T. When you do that, then you're going to use that to find its p-value. What is a p-value? The lowest level at which we would reject your null hypothesis. Okay, so one more time. Your p-value is the lowest level at which you would reject your null hypothesis. Okay. So I have to find my test statistics. So, and do you see this on your formula sheet? Stat minus parameter over standard deviation. Okay, so for proportions, it's a Z. If for means, it's a T. Everybody good so far? You sure? Statistic is your P hat. Parameter is your P. Statistic is your X bar. Parameter is your mu. Everybody good there? Where do I get these guys from? They are your standard deviation from the front of your formula sheet, which we really should have memorized by now. And I want to remind you that your PQ down here is from the population again. They do not have hats. They should not have hats because it's from the population. No, because, I mean, we have to know the population proportion because it's in our null hypothesis. Okay, so now I have a Z. I don't know, let's say Z is 2.59. Okay, so what do I do with him? I need his p-value. I need the area. So I draw my curve. 2.59 would be here. And I want that area because that gives me my p-value. Then what do I do with my p-value? Do you remember the line? And I compare my p-value to my alpha, and I decide if I'm going to reject or accept. Okay? Now, this would have to be a right-tailed test. So what would that look like here? It would have to be greater than. What if this happened to be a not equal to? I can still get a positive number, but what do I have to do to this area? Do you think that is a common mistake? So if they're going to give you this, odds are it's going to be a two-tailed test because they want to make sure that you pick up on that. Since our p-value is greater or less, and I'm going to refresh your memory, then we Then our level of significance for this test, we either reject or fail to reject H sub 0. There is or is not enough convincing evidence to conclude, and this is always your H sub A, your alternate. Either we've rejected this, so there is enough evidence to conclude my H sub A, or we failed to reject this, there is not enough evidence to accept my H sub A. But this sentence is always about my H sub A, my alternate. Our data is or is not statistically significant. That sentence that I always seem to forget. And then you conclude a sentence of relevance if applicable. Billy Bob's mom should get him out in front of the TV. Yeah.
Your null hypothesis, that H should be the same as its standard deviation.
Correct. Correct. All of this is the same except for here, upper lower degrees of freedom. Everybody good there? And all of that is the same. Everybody okay? Okay, so now let me see if I can slide this guy down and over so I can see him. Come on, baby. There we go. Okay, just ignore. Okay, cool. Okay, difference. It is a one sample matched pair, not a two sample. We haven't talked about two sample yet. If it's a matched pair, it's one sample. I'm going to say that again. If it's a matched pair, it's one sample. I'm going to test you before I teach you stats, and then I'm going to teach you stats, and then I'm going to test you after stats. Where's my sample? You guys. That doesn't change from test to test. I have one sample, but I have two different results that I'm going to pair together through this one sample. The true mean difference, and you have to define what your difference is. Do you remember that? Because we could define them differently. It changes everything. You define it, what makes sense to you, and you roll with it. Don't be lazy. All right, we got random, we got independent is not needed because most of the time this is some sort of experiment. Normal is all the same. Do you remember your terminology down here, your variables? What's the sub D? Difference. It stands for difference. You need that there. You need that here. And you need that there. And I think the standard deviation of the differences is one that would be really easy to overlook. Your null is that there is no difference, and your alternate, this is based on however you set it up. However you set it up, you need to think about if you've got mu sub pretest minus mu sub post-test, what would I expect to be bigger? The post, if I'm talking about average grades. So my post would be bigger. So what would my difference be?
You would want it to be negative.
Would want it to be negative because this would be a small number minus a big number. So my mu sub d, I would want to be less than 0 if I set it up this way. Now, if you set it up post minus pre, then I want my difference to be positive.
So whichever way you set it up is what it's supposed to be.
Exactly. As long as you're consistent, you're fine. Yes. Here? Is that what you're talking about? No.
But then it carries down.
Yes. So this guy, do y'all remember, who is he? And some of you would get here and be like, I don't know who mu sub d is. Well, mu sub d is 0 because what are we assuming? That there's no difference. That's our null, that there's no difference. So that will always be a minus 0.
On our alternate, is it always less than, greater than, or not equal to 0?
Yes. Yes. Did y'all hear that? On your null, no, on your alternate, it's either greater than, less than, or not equal to 0. Either it's not 0, or it's less than 0, or it's greater than 0. So you have to decide if you want a negative difference or a positive difference, or just saying that there is a difference. Let's see. These are T's because this is a mean. How do I get, let's see, how do I get him and him? I have your scores from your pretest. I have your scores from your post-test. Nope.
Do we have to do 2 differences?
Nope. I don't want this data individually. No.
Oh, isn't it
No. I give you pre-test data. Guys, focus. I give you post-test data. You hop on L3. You go up on L3. And you do, or L2 minus L3, however you want to do it. So that's in L3. Now, how do you get the mean and the standard deviation of your differences?
Variable stats.
You do one variable stats, but you tell it L3. And that's where you get that data from. Sometimes they will give you this data and this data and this data. They'll give you a chart that shows you the differences. So then you just plug all this stuff into your L1 and do one variable stats on L1. Sometimes they're not gonna. If I wanted to crank it up, which is what I would want to do on an AP test, I'm not going to give you the differences. I'm going to make you go find them. Does everybody remember you get your little cursor up on the L3 and you type in L1 minus L2? Okay. Don't forget to double your answer if it's two-tailed, and that's if it's a not equal to, and then all this is the same. Okay, so now flip your sheet over. Do you have this? So this is other words of wisdom that I made after I did your homework. Okay, remember this guy. You set your p-value. What do you do up here? You reject, because your p-value is the lowest level for which you would reject. So if your alpha falls in here, if my p-value is a 0.06 and my alpha is a 0.05, I fail to reject, because this is the safe zone. He falls down here. He's good. He's free and clear. If he's up here, that's bad. My alpha is 0.05. In this case that I just made up, yeah. Well, if so, this is 100 and this is 0. Got it now? So if you have a really tiny p-value, odds are you're going to reject. If your p-value is a little bit bigger and your alpha falls down here, then you're good. You're okay. You can fail to reject. Did that just sink in? Because that needs to, okay.
rejecting it without rejecting A or H sub A?
No. H sub 0, you're null. Yes. And it all depends on where A falls. These always use parameters, not statistics. We just talked about that. Okay, let's talk errors. And I'm sitting here at my desk doing the homework, and I'm still like, hey, if this is true. So a type 1 error means you pick that one. I pick this one down here at the bottom. But this one was really true. And guys, on the multiple choice, I have to write it out. And I write this and this beside it, so I know what it is that I'm trying to interpret. A type 2 error means you pick this one, but this one's really true. Alpha is the probability that there's a type 1 error. Put that in your brain right now. Alpha is the probability that there's a type 1 error. Beta, which we didn't use that much, is the probability that there's a type 2 error. Power of a test, y'all remember him? Vaguely. We didn't do a lot with him, but he's there. He's not on your formula sheet. That's something that needs to go in your brain. Increasing the sample size increases the power of the test. Is that logical? Increasing the sample size increases the power of the test.
How do you solve for these? Oh,
1 minus power.
power of the
Yep. And ask you for the other one. Okay. Now, what I have done is I have pulled 3 problems. One is a proportion, one is a mean, and one is a difference of means. I don't want you to have anything on your desk but your formula sheet. Nothing. Because we're going to do this in your brain from scratch. I do not want you looking at it. But I know that you would want it, so I've made you copies of all three of these problems so you have them. You don't have to write anything down. Sound good? Trying to maximize our time here. Okay, so nothing on your desk. I don't want anybody looking. You can have your formula sheet because you'll have that on the test, but and I've got it covered up, I want us to go from scratch. Okay, ready? Publishing scientific papers online is a fast, and the papers can be long. Publishing in a paper journal means that the paper will live in libraries forever. The British Medical Journal combines the two. It prints short and readable versions with longer versions available online. Is this okay with authors? The journal asked a random sample of 104 of its recent authors several questions. One question was, should the journal continue using this system? In the sample, 72 said yes. Does the data give good evidence that more than 2/3 of authors support continuing the system? Carry out an appropriate test to help answer this question. Okay, in your brain, is this a one sample or a two sample? One sample. Is this a Z or a T? Z. Why? Because it's proportions. Everybody good there? Got it? That would be the first thing that you write. Okay, what's next? Define your parameter. What is our parameter? P. Okay, so P equals the true proportion of all recent authors of, who said yes to supporting, somewhere along those lines. Okay, let's see what I wrote. The true proportion of all authors, and see, I think I would go more detail in that, who support this journal system. Everybody good? Okay. And do you see this? There's my sample size. Why is that my p hat? That's my sample. I have a sample size, and that's how many out of the sample. Now, do you see that that's my p? Now, do you guys see that you have a p and a p hat? So when you go set up your null and your alternate and your PQ over in and all that stuff, you got to know which p to use. Which p do I use? 0.67. So I start with my null and my alternate. Everybody good there? So my P, and do I want greater than?
Yeah, because you'll end up with more than.
Let's see. Does the data give good evidence that more than? Everybody see that? Okay, so that's him. I added my alpha. Here are my conditions. I got random. Yes. Independent. What are we assuming? 1,040. There are 1,040 authors. And my large count, notice my 0.67, that's my P and my Q from the population, not the sample. Okay, so now this is when I panic and I don't know where to go, so I go to the back of my formula sheet and I find my test statistic. And so I write it in words. I hope I wrote it in letters. Oh, I did. There he is in letters. Letters all make sense. Everybody okay? So then that's my sample, and if you want to go and change them to a decimal, that's fine. There's the population, sample size. Now when you type this in, be careful. Like I would subtract the top and hit enter, and then divide it by the square root of all that stuff. It gives me my test statistic. Now, what is his purpose? To find my P. So then I come over here and I draw. Now he's positive, so he lives over here, and we shade. And I normal CDF because I'm, but I normal CDF because I'm a Z, not a T. There's my lower, there's my upper, there's my 0, and my 1, which I should have written above that. And now I have my p-value. Do you remember, you don't ever write that number without telling me what it is? P-value, because that's one of the things they're going to be looking for. That is my p-value. Okay, now, that is 31.4%. That's my p-value. This is reject. This is fail to reject. My alpha is 5%. Where's my alpha? Way down here. So are we good? We're good. We fail. All right, write me a sentence. Since our p-value is greater than the, for this test. Yes, you're right. Absolutely. Look, there he is. H sub 0. There is not enough convincing evidence to conclude that true proportion of all authors support this journal is greater than 67%. That was beautiful. Our data is not statistically significant. Of course, the sentence that I always forget. Okay, let's see how we did. Because our p-value is greater than the level of significance for this test, we fail to reject H sub 0. There is not enough evidence to conclude that the proportion of authors for this journal who support this system is greater than 67%. Our data is not statistically significant. Could you rock this problem? Okay, juicy pineapples. At the Hawaii Pineapple Company, managers are interested in the sizes of pineapples grown in the company's fields. Last year, the mean weight of pineapples harvested from one of the large fields was 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wondered how this change will affect the mean weight of future pineapples grown in the field. To find out, they select and weigh a random sample of 50 pineapples from this year's crop. The mini tab output summarizes the data. Remember, they're going to give you these and you have to know how to read them. So here's my variable. There's my sample size, my mean. There's your standard deviation over here. This is your standard error mean. Don't use him. Then it says, does this data give convincing evidence that the mean weight of pineapples produced in the field has changed? What are you? You're a not equal to. Can we conclude, and there's a follow-up question that's really easy to forget to go back and answer. Can we conclude that the different irrigation system caused, that's a powerful word, caused the change in the mean weight of pineapples produced? Explain your answer. Okay, here we go. Do you agree that we are a one-sample t-test for means? Yes. One sample, t-test for means. Mu is the true mean weight of all pineapples grown using the new irrigation system, not just all pineapples grown, but now we're talking about the new ones grown with this new cool irrigation system. And this is just me writing out what I got from the mini tab. Conditions. I'm random. It said random sample. I'm independent. What are we assuming? At least 500 pineapples grown with this new irrigation system, which is, I would. I really like that sentence. Normal, CLT applies. You would write a little bit more than this. CLT applies because our sample size is bigger than 30. And then this is where I panic and I go to my formula sheet and then I calm down. So my test statistic is my T. There's my stat. There's my parameter. There's my standard deviation. Stat is from the mini tab. Parameters from my null and my alternate, which I have down there. There's my standard deviation and there's my sample size. When you type this in, if you want to do it in one swoop, do that in parentheses, but then what do you have to do with that? It has to be in parentheses to show that you want the whole thing on the bottom. So be careful there. And when you're doing your homework, you'll practice this. So there's my test statistic. What is his sole purpose? To find my P. So then I calm down here. Now, why'd I do 2? Because it's not equal to, and that's how you know that you're doing 2. So I have the positive version and the negative version. I'm TCDF. Why? Because these are T's, because this is a mean. So a TCDF, I pick the positive one. Positive to infinity, and who's that? N minus 1, so 50 minus 1 is 49. You're going to show all that because they love that. And I got my p-value. That's tiny. I have to times it by 2. Did I times it by 2? Oh, I put my 2 here. I times it by 2 from the beginning. Okay? This is tiny. What does that mean? I'm probably going to reject unless my alpha is microscopic. And our alpha is 5%, so we're going to reject. Since our p-value is less than the level of significance for this test, p-value is less than alpha, he is less than him, we reject h sub 0. We have enough convincing evidence to conclude that the mean weight of pineapples grown with a new irrigation system is not 31 ounces. Our data is statistically significant. No, it did not cause a different weight. There could have been other factors, such as soil, rain, a hurricane, weather, bugs, whatever. Yeah, it asked specifically. You can't say that. Can't say. That's okay.
So, like, for all different things, like, not sure if it better just to not read it.
Yes, if you're not sure, don't go there. This one we had to because it asked. Okay, last one. I can't get through my day without coffee. I remember this problem. Do y'all remember this one? I think this one came from a test review. All right, so let's see. I can't get through my day without coffee is a common statement from many students. Assumed benefits include keeping students awake during lectures and making them more alert for exams and tests. Students in a statistics class designed an experiment. Got that? Experiment to measure memory retention. So no, it's not about them being mad. Memory retention with and without drinking a cup of coffee 1 hour before a test. The experiment took place on 2 different days in the same week, Monday and Wednesday. 10 students were used. Each student received no coffee or 1 cup of coffee. Treatments were randomly assigned. Right there is when you know what. It's a matched pairs because it's 1 sample. Because I'm doing both treatments to 1 person. Does that make sense? Huh? Right. Let's see. The test consisted of a series of words flashing on a screen, after which the student had to write down as many of the words as possible. The data from the experiment are provided in the table below. And did they give us the difference? No, we have to find it. Set up and carry out an experiment to test to determine whether there is convincing evidence that drinking coffee improves memory. So if this, and I can't remember how I set it up, but if this is the first one and this is the second one, which one do I want to be bigger? The second one. So I want my difference to be, if I want him to be bigger, then my mu sub d needs to be less than 0. How's that process? Okay, good. It's a 1 sample, because all matched pairs are 1 sample. T-test for difference of means. Good there? Mu sub d, the true mean difference, and I had to define it, no coffee versus coffee, and I just left it in the order that they had it. And the number of words were called on a test without coffee and with coffee. Then this is my null and my alternate. This is me figuring out should it be positive or negative, which is what we did over there on the side. Everybody so far so good? My conditions are random. Yes, the treatments were randomly assigned. Independent, not necessary because? You got it. Normal CLT does not apply because 10 is not greater than 30, and normally for matched pairs, it's a small number. So I draw my box and whisker. I have no whiskers. What does that mean? That means that 50% of my data is here and the other 50% of my data is there. But it definitely has no strong skewness, and it definitely doesn't have any outliers. I even wrote, it doesn't even have any whiskers. Then I found, let's see, I did L1, L2, and in my L3, I did L1 minus L2, and then I did 1 variable stats on my L3 to get them, but you make sure you label those numbers correctly. That's X bar sub D, not mu sub D. X bar sub D and your standard deviation sub D. It's the standard deviation of the differences. So that's where he came from. Then I go to my formula sheet. I get my words. Then here are my letters. Everybody good there? That came from here. Who's he?
That's your mu sub D.
That's my mu sub D from my null hypothesis. He's my standard deviation from way over there, and there's my sample size, and that gives me my T. What is his sole purpose? Okay, so I come over here. He's negative. Does that make sense? Yes. Where's my... Aren't we left-tailed? Okay. So left-tailed, and I TCDF because it's means. So negative infinity to him, and who is he? Degree of freedom, 10 minus 1. And I got my p-value, which is tiny. So odds are we're going to, since our p-value is less than the level of significance for this test, we reject h sub 0. There is enough convincing evidence to conclude that the mean difference, defined what that was, in word recall is less than 0. In other words, and this is does like a make a sense kind of a statement. In other words, we have evidence that students will remember more words with coffee than without on average. It is statistically significant. Of course I forgot it. It is statistically significant. Could you use the word cause here? Yeah, absolutely. And that's kind of implied here. I didn't use the word cause, but I have will. But you could absolutely have the word cause in here. That would be totally fine. What do you think? You're correct. For a test, you're not going to have a critical T. You're going to have a T or Z. There's a multiple choice problem on your homework tonight that asks you to interpret the p-value. It comes back, it's multiple choice, guys. And it comes back, because when I read it, I was like, oh, that's perfect. It's perfect. And it's exactly how I taught it, and it will come back. It should come back. Okay, I think that's it. Okay, now, pull your homework out. You have a copy of all 3 problems that I just went over, and everything is filled in. Okay, so those are your notes. Your homework. Get your Princeton book. Princeton book, you have 2 multiple choice, number 2 and number 4. And the free response, number 10, that you've already done part A for, you need to do part B. Now, guys, when you do part B is a test, obviously. Do you need to redo your conditions? No, you need to say conditions were met in part A. Because think about it, you're doing this problem continuously. So there are parts of part B that you don't have to go do again. Your multiple choice has 15 problems and 2 excellent free response questions. I want you guys to nail this, okay? On this multiple choice, there are 15 of them. I really want you to miss like 5, and that's it. Really see if you can set the bar there. And on your free response, I want 4s. I want solid 4s. There's nothing tricky about these. You know every component that you need. I want 4s on these, okay? So I want you to really kick butt on these over the weekend and Monday night and come in Tuesday with this rock solid. Tuesday, we're going to do the differences of proportions and means, and then Thursday, we got to do chi-squared. Then I will see you Monday in class, and I will see you Monday afternoon for our review session, and I will see you Wednesday morning, the day of the test. We'll have class. Some of you won't be here because you'll be taking another AP exam, but I'll be teaching for the rest of you who are here or reviewing. Okay? All right.